Welcome to Precalculus lesson number 2. In this lesson, we're going to learn about applications and modeling with linear equations. We're going to use a simple three-step approach to solving applications. The first step involves understanding the problem. Even though that sounds quite obvious, unfortunately, too many people try to rush to an answer and they don't pay enough attention in the initial phase of the problem. So sometimes you have to read a problem once to understand it. If it's stated in a very simple manner, sometimes you have to read it 3-4 times before you know exactly what's going on. But basically, before you move on to step 2, you have to make sure you know two things. Firstly, what is given, what kind of information is the problem giving you, and secondly, what is wanted. You have to be very clear about those two facts before you proceed. Once you've done that, and that step entails maybe drawing a little drawing or a table or some sort of method to kind of organize your information that's given, then you go on to the second step, which is to translate from English to mathematics. This is where you use the variable that you've probably went ahead and defined in your first step to go ahead and form an equation or an inequality. And then once you've done that, the last step is the easiest step. You go ahead and solve it. But before you move on, you make sure that you answer the question that's asked. As we will see, sometimes just solving the equation or inequality isn't necessarily just the simple answer that they want. So sometimes you have to do a little bit more work to get one or more of the questions that they've asked. So let's move on and take look at a couple of examples. All right, so in this example, we have two sides of a triangle that have the same length. We know from geometry, another way of saying that is that we're dealing with an isosceles triangle. The third side measures 4 meters less than twice the common length, meaning the length of the two sides that are the same. The perimeter of the triangle is given to be 16, and we know the perimeter is just the sum of the three sides of the triangle. Now we want to know the lengths of the three sides. Okay, so this is a simple enough scenario, so I think we have a basic understanding. We do know that these two sides are the same, but we don't know what the length is. So why don't we go ahead and just give them a name like x. Now, we don't know the third side either, but we have a relationship between the third side and this common length, right? It measures 4 less than twice the common length. So when you see an expression like that, less than something less than something else, start with what comes after less than first. So twice the common length will be 2x. Now reduce that by 4, so minus 4, like that, okay? So we know that the perimeter of a triangle, we've kind of gone through the first two steps, right? Well, the first step of understanding, we're ready to go to step 2, which is to translate, right? We know that the perimeter is the length of the three sides, side 1 plus side 2 plus side 3, right? So we plug in everything we know. We know the perimeter is 16, right? So inside the equation, we usually don't need to put the units, but we make sure our final answer has the proper units. So we get 16 equals, now I'm just going to use these two for S1 and S2, so I get x plus the third side, S3, which is going to be this length, 2x minus 4. See? Now that we've done that, as I said, the last step is the easiest. Just solve that, you should be good to go. So we get 16 equals, if we combine these three terms, we get 4x minus 4. Now we'll just solve for x by first adding 4 to both sides to isolate the x term. So we get 20 equals 4x. Now we just divide both sides by 4. So we get x equals 5. So now we have to make sure we're answering the question asked. What are the lengths of the three sides? So we don't just want that length, we want this length as well. But that's easy because that's just going to be 2x minus 4 which now we're going to use 5 for x, so we get 2 times 5 minus 4, so we get 10 minus 4, which is 6. So now we will answer the question properly. What are the lengths of the three sides? Well, 5 meters, 5 meters, and 6 meters. That's how you properly handle a problem like this. Make sure you can do this on your own before we proceed. All right, for this next problem, we have a recycling bin in the shape of a rectangular box as depicted here. Find the height of the box. If its length is 18 feet, we're given the length. Its width is 10 feet, right there. And the height is what we want to find, so we'd go ahead and call it h because we don't know what it is. And we do know the surface area. So that's the area of all the sides added together. That gives you the total surface area. And we know that that surface area is 640 square feet. Assume that the given surface area includes that of the top lid of the box as well. Okay, so we've already done some of the understanding phase by looking at this diagram and labeling it. So the next thing that we need to understand is the fact that the surface area is given to us. Now, the surface area, of course, is going to be twice the area of this front piece that we see, plus twice the area of that piece, because there's one on this side, one on that side. For the front, there is one here, one in the back, and then there is the top piece and the bottom piece. So twice the area of the top piece will do as well. So we notice that we can get the area of, for example, this front face by multiplying this length by the height, which of course, if that's h in the back, this is h as well, right? So for this part here, we're going to have 18h, right? It's just the area of a triangle. And for the side piece here, notice that we need to multiply 10 and h, so that part is going to be 10h, and the top piece is going to be 18, right, by 10, which is the same as the bottom piece, 18 by 10, right? So 18 times 10 will give us that piece, or rather the area of the top part and the bottom part, that's the same. So we know that twice the area of the, let's say, front, so 2 times 18h, plus twice the area of the sides, which is 2 times 10h, plus twice the area of the top, right? So 2 times 18 times 10 is 180. All that, when you add all those surface areas, you should end up with the total surface area, which is 640, right? So basically, there's our translation. Now we just need to solve. So 36h plus 20h plus 360 equals 640. So 56h plus 360 equals 640. So now we're going to isolate the h term by subtracting 360 from both sides. So we end up with 56h equals, we'll use some technology here. So 640 minus 360. Sorry, that was a very loud motorcycle. All right. So we get 280. So now all we have to do is divide both sides by 56h. 56, not h. So what do we get? All right, so let's divide that by 56. So we end up with 5. So h equals 5. So to answer it properly, of course, we're going to need the right units. So the height is 5 feet long. Okay? And that's all there is to that. Okay, so in our next problem, we have a rate, time, distance problem. Margaret drove to a business appointment at 40 miles per hour. Her average speed on the return trip was 30 miles per hour. The return trip took 1/3 hour longer because of heavy traffic. How far did she travel to the appointment? So in our effort to understand this, first of all, we note that she's going from home to work, right? Or a business appointment, let's say, like this. And then she's coming back the same route, basically. So the distances are going to be the same. That's going to be of crucial importance to us later on. The next thing that we need to understand is that on the way from home to the business appointment, the speed was 40 miles per hour. And so when going in this direction, she was going at 40 miles per hour. And when coming back, she was doing that at 30 miles per hour. Slowed down because of traffic. All right, so the best way to approach problems like this is using a table. But in order to set up a table, you need to know the formula that's going to be at work here. The formula at work here is, of course, the simple rate times time equals distance formula. So we'll go ahead and make our table using that fact. So the categories are going to be home to business appointment and the return trip, business appointment to home, right? So we put the proper titles for the columns of our table. Now we plug in any information that we know. We know that when she was going from home to the business appointment, she was going at 40 miles per hour. One thing we can do is in our table heading, we can put the units, miles per hour. The time is going to be in hours, and the distance is obviously going to be in miles, right? So that we don't have to keep writing the units in every box, okay? So we know that the rate, which is the same as speed, was 40 on the way from the home to the business appointment. On the way back, it was 30. We know that it took her 1/3 of an hour longer to get back. So we don't know how much the time was to get from home to the business appointment. So we'll just call that T, right? But we do know whatever that was, this one was what? More by 1/3. So we just say T plus 1/3. And now I can use this formula to get a distance expression for each of the directions. So for the direction from home to the appointment, it's going to be 40 times t, which is 40t. And for the return trip, it's going to be 30 times t plus 1/3. Of course, what's going to really help us solve this problem is the fact that these two distances are obviously what? The same. So that's the key thing to understand. So we get 40t is equal to 30 times t minus 1/3. I'm going to go ahead and distribute that 30, so I get 40t equals 30t. Let's be consistent, we're using lowercase t, so let's stay with that. Now, at any point where you feel like, okay, I've got this now, right? Then go ahead and stop the video and finish it on your own. And always try to do it from the very scratch, from the beginning. But if not, at any point where you feel like, okay, I got the rest, then continue on your own. So, and then minus 30 times 1/3. Of course, I'll show that on the side here. 30 times 1/3, that's like 30 over 1. So they cross cancel, they just give us what? 10. So minus 10. So now we'll get the t's on one side by subtracting 30t from both sides. So we end up with 10t is equal to, oh, this was a plus. Let's fix that. So be careful here, I accidentally wrote a minus, it's plus. So it's 30t plus 10. So we subtract that, so we end up with 10t equals 10. So now divide both sides by 10, we get t equals 1, okay? So is that the question they asked? What was the time that it took her to go from the home to the appointment? No. See, that's what I was talking about, that you have to make sure you answer the question that's asked. So the question is, how far did she travel to the appointment? So either of these two distances should do, right? So which one is easier to calculate? This one. So the distance from home to the appointment, which is actually what they asked for anyway, is just going to be 40 times 1, because it's 40t and t is 1. So it's going to be 40. Now, do give the final answer with the proper units. Of course, that's going to be in miles, okay? So now, just out of your own curiosity, you should make sure that this gives you the same answer, because this, after all, should be the same distance, right? So let's just do that as a little bonus. Let's do 30 times 1 plus 1/3, right? Now, I'm not going to sit here and try to combine those or anything like that. I'm just going to use the distributive property. So I get 30 plus 30 times 1/3. So that's 30 plus 10, which is, of course, also 40. So there you have it. Again, always make sure to answer the question that was asked. And watch your signs. Don't make the same mistake that I did. And if you do, you will catch it at some point. Like here, obviously, why did I immediately know that something is wrong and caught it? Because here I ended up with a what? I would have ended up with 10t equals negative 10, and I would get a negative time. So that's what immediately woke me up, right? Like, whoa, this can't be. So I realized instead of a plus here, I had written a minus, so I fixed it right away. So, but anyway, you do want to be careful throughout, but as long as you're alert, you'll catch yourself very quickly. All right, so make sure that you can do that problem on your own before we proceed. All right, here we have another one of these rate, time, distance problems. We have two high-speed ferries that leave at the same time. Again, that's going to be a crucial piece of information from a city to go to the same island. The first ferry, the Cat, travels at 37 miles per hour. The second ferry, the Bird, travels at 27 miles per hour. In how many hours will the two ferries be 40 miles apart? So if we try to get our information kind of in a graphic manner, we notice that they do leave at the same time. So we have the Cat and the Bird, right? And they leave at the same time. So since the first one, Cat, is traveling faster, right? She's going to be ahead of Bird, right? So our question is, how far ahead? Well, how long will it take before Cat is this distance, which is let's see, the bird traveling 40 miles ahead of bird, right? All right, so bird is here, cat is here, right? So bird is here, cat is here, obviously 40 miles apart, okay? So in order to do the problem, we are going to utilize the same kind of table that we did in the previous problem, but of course, we'll set it up a little bit differently. So our two categories here are going to be cat and bird, right? Of course, the table is going to look similar. We're going to have rate, time, distance. All right, so what do we know? Let's put the units in our headers so that we don't have to keep putting them in every box. So this is miles per hour. The time will obviously be in hours and the distance will be in miles, okay? So we know that cat travels at 37 miles per hour and bird travels at 27 miles per hour. Now we know that they're going to be in motion the same amount of time when this event happens, which we're interested in, when cat gets 40 miles ahead of bird, right? So we don't know what the time is, how long that takes, but we can just call it a given name, right? So they're both in motion the same amount of time. We know the distance from our rate times time equals distance is going to be 37t for cat and 27t for bird, right? We also know that the total distance that cat has traveled by that time is going to be whatever distance bird has traveled plus 40, right? So we can put it like this. We can say dc equals whatever db is, because remember this part here is the same as what? dB, and then plus 40, right? So what is dc? Well, that's right here. This is what we mean by dc, and this is dB, right? So we have 37t, and remember, at any point where you feel like, okay, I have it from here, just go ahead and pause the video and finish it on your own. Equals 27t plus 40, right? So now we'll get the 27t on the other side by subtracting 27t from both sides. We end up with 10t equals 40. Now, if we simply divide both sides by 10, we get t equals 4. So there we have it. So basically, in how many hours will the two ferries be 40 miles apart? We can say in 4 hours. We always give our final answer with the proper unit. Okay, so you can see how simple these things can be if you approach them the right way. Trying to jump to an equation and to an answer is never going to work in a very successful manner. So take your time, do your little drawing, try to understand the problem. Then you can, the table itself is also part of the understanding. Then you translate, go ahead and make your equation, and then you solve. Just make sure you answer the question asked. In this case, the answer, the solution to the equation was the answer they were seeking. So this was very straightforward in that sense. All right, so if you didn't do it on your own at first, try to just put everything away, look at the question, try to do it all on your own without any help, and then you'll be in great shape. All right, this next rate time distance problem we're looking at is part of a class of problems that we call boat in a river. So boat in a river. We write it just like that with dashes in between because we want to say it as one word. So this is a boat in a river type of problem. And it requires a certain kind of understanding which we'll go through before we actually try to set it up. So the point of this kind of problem is that, let's say we have a river here, right? Rivers usually have a particular speed, right? So we call that speed C for the current, right? So if, as it turns out, if you are going in the same direction as the current, and your speedometer shows a certain speed, right, B, well, that's not the actual speed you're moving at, because what the speedometer is showing you is that based on how hard my engine is working, this is the speed that I would go if I were on a lake, for example, on still water, right? So what you see on your speedometer is what you would be going if you were on a flat, waveless and windless situation or currentless situation. So the actual speed, so the rate going, and this is called downstream, right, would actually be whatever the speedometer shows, and then the speed of the current would be helping you by that much. So it would actually be B plus C. See? So whatever your speedometer shows you plus whatever the speed of the current is. Now, let's say later on you're going back home up the river, right? So this time, whatever your speedometer is showing, again, is not going to be your actual speed, because this time the current is going to be fighting you. You're going against the current. So the rate going upstream is going to be B minus C. You see what I mean? So in one direction, the speed of the current helps you. In the other one, it slows you down. So now that we know how that works, we can set this up, okay? Jane took 20 minutes to drive her boat upstream to water ski at her favorite spot. Coming back later in the day at the same boat speed took her 15 minutes. If the current in that part of the river is 4 kilometers per hour, what was her boat speed in still water? So they're giving you the speed of the current, they're giving you C, and they want B, right? And one thing to keep in mind is that they're giving you the speed of the river in kilometers per hour. You have to pay close attention to that, because that means we're not going to use these 2 times. Instead, we're going to use their hour equivalents, right? So let's keep that in mind. Let's go ahead and set up our table. Categories here are going to be upstream and downstream. Our headings are going to be similar to the other problems: rate times time equals distance. And now we don't know that the rate. Now we do know the speed of the current, and we know the times, right? So for upstream, we know that the time was 20 minutes. So remember, we're going to convert 20 minutes by multiplying by 1 hour over 60 minutes. That's called the unit factor, because the top and bottom represent the same quantity, right? So now we cross cancel and we get 1/3 of an hour, right? For the 15 minutes, we do the same thing. So we say 15 minutes times 1 hour in 60 minutes. You want to make sure that your minutes for the unit factor are on the bottom so they cancel out, just like we did here. So again, this time they cross cancel, leave you a fourth. So this is going to be 1/4 of an hour, okay? So again, the rate here is going to be in kilometers per hour. Time will be in hours. The distance will be in kilometers, okay? Now, we know that the time upstream is the 20 minutes, so 1/3. The time downstream was the 15 minutes, which is 1/4. Obviously, because the downstream time is going to be less than the upstream time. And the other thing that we know is the speed of the current. So we don't know the speed of the boat. We're going to leave it as B. But I know that when I'm going upstream, my speed is going to be B minus the speed of the current. And we know the speed of the current is 4. So B minus 4, right? And going downstream, the speed is going to be whatever the speed of the boat is plus the speed of the current. So this time it'll be B plus 4, right? Now, what about the distance? Well, remember, rate times time equals distance. So 1/3 times B minus 4 will be my distance upstream, and 1/4 times B plus 4 will be my distance downstream. So I want you to think for a minute about the relationship between these two distances, right? Remember, she's going from point A to point B and then coming back from point B to point A, right? So these distances are what? They're the same. That's where in other words, we know that the distance upstream is the same as the distance downstream. So that's where our equation is going to come from. 1/3 times B minus 4 is going to be equal to 1/4 times B plus 4. Now we can quickly get rid of these fractions by multiplying by the LCD of both sides, which is 12. So we go ahead and multiply both sides by 12. We notice that you can cross cancel. 3 and 12 on the left give me 4. 4 and 12 on the right leave me 3. So the simplified equation with no fraction is going to be 4 times B minus 4 equals 3 times B plus 4. So now we just have to go ahead and distribute. So we get 4B minus 16 equals 3B plus 12. So let's subtract 3B from both sides to get the B's on one side. And let's go ahead and add 16 to both sides to get the numbers on the right side. So we end up with B is equal to 12 plus 16, which is what? 28. Now we'll answer the question properly. What was her boat speed in still water? Remember, that was B. So again, simple, straightforward. So now we're going to answer 28 kilometers per hour, like so. Make sure your final answer always has the proper units. All right, so once again, if you haven't done this on your own already, make sure you do before we move on. Okay, for our next problem, we're going to change things up a bit and look at a slightly different kind of problem, but the thinking process is very similar to the problems we've already done with rate, time, and distance. Here, we're dealing with a problem like this. How many gallons of a 70% antifreeze solution must be mixed with 80 gallons of a 20% antifreeze solution to get a mixture that's 60% antifreeze? So the situation is simple. We're going to mix two types of solution to get a different kind of mixture. That formula that we need to understand is the following. that the concentration of any given ingredient which is basically the percentage or strength of that ingredient times the amount of solution is going to equal to the amount of the ingredient in that solution. So as a real simple example, imagine you have 100 liters of 20% alcohol solution. So you want to know what's the actual amount of alcohol in that 100 liters, right? So you would take the 20% and multiply it by the 100 liters. And that, of course, is going to be 20 over 100 times 100, or just 20 liters. So that means you would have 20 liters of actual alcohol in that mixture, right? So this is the way that we're going to set up our table. We are going to do these as well using a table. So we'll set up a table. The categories will be the kind of solutions we're mixing. We're mixing a 70% antifreeze solution with some 20% antifreeze solution to get some 60% antifreeze solution. So in our headings for our table, we're going to have the concentration of antifreeze, we're going to have the amount of the solution, and then when we multiply those, we'll get the amount of the ingredient, in this case the antifreeze, in the solution. All right, so now we're going to fill out as much as we can in this table. The concentration of antifreeze, of course, is just the percentage, right, of the antifreeze in each solution. For the first one, clearly it's 70%. We're going to use the decimal equivalent of 70%. Remember, 70 over 100, that's 0.7, right? So 0.7. For the 20% antifreeze solution, it'll be 0.2. And for the 60% antifreeze solution, the concentration of antifreeze will be 0.6. Now, we don't know how many gallons of the 70% antifreeze solution we're going to use, right? That's what we're trying to find out. So this is going to be X. We know how much of the 20% antifreeze solution we're going to mix. We're going to use 80 gallons. So remember that this is going to be in gallons, and so will be the amount of the antifreeze in the solution. So we do know how much of the 20% antifreeze solution we want. It's 80 gallons. I put the gallons up here on the heading, so I don't need to put it in every box, okay? And do I know how much of the 60% antifreeze solution I'm going to get? Well, not exactly in a numerical sense, but I know it's going to be however much this is plus however much that is, right? So that'll be X plus 80. All right, so the first multiplication here, 0.7 times X, that's going to be the amount of antifreeze in the 70% solution, right? When I multiply these two, the 0.2 and the 80, remember, that's going to be the amount of antifreeze in the 20% solution. And when I multiply these two, 0.6 by quantity x plus 80, that's going to be the amount of antifreeze in the 60% mixture, right? Now, given that I'm mixing these two to get this, that means however much antifreeze comes from the first solution, the 70% solution, plus however much pure antifreeze there is in the second solution is exactly going to be the amount of antifreeze in my 60% mixture. So that's precisely, this last column is where my equation is going to come from. So I'm going to get 0.7x. Let me explain in writing what it is. So remember, we're just saying the amount of antifreeze in the 70% solution plus the amount of antifreeze in the 20% solution should equal the amount of antifreeze in the 60% mixture. Why? Because we've mixed those to get this one, right? So however much antifreeze was there plus however much was there should be however much is in the mixture. So the equation is 0.7x plus 0.2 times 80 is equal to 0.6 times x plus 80. Now that equation is relatively simple to solve. We'll get rid of the decimals by multiplying both sides by 10. Remember, because of distribution, that means every term is going to get multiplied by this 10. And once we do that, we end up with just 7x plus 2 times 80. Don't forget, once you multiply the 10 and the 0.2 and get 2, that means the 10 is taken care of. You don't multiply it also by the 80. There's not a sum here where distribution is needed. This is just a product, right? And on the other side, we get 0.6, 10 times 0.6, which is 6 times x plus 80. So all we have to do now is solve this much simpler equation with all whole numbers. So we get, let me continue up here. So we get 7x plus 160 equals 6x plus 480. So now we'll go ahead and move the 6x to the other side by subtracting 6x from both sides. And we'll move the 160 to the other side by subtracting 160 from both sides. So now we get x is equal to 480 minus 160, which is 320. And that's exactly what we were looking for. We were looking for how much of the 70% antifreeze solution we have to add to this 80 gallons of the 20% antifreeze solution to get our 60% antifreeze solution. So the answer to the question is simply 320. Don't forget the units on the final answer. Now, they didn't ask us for how much of the 60% antifreeze solution we end up with, but in case they do, that's easy to figure out, right? That's just going to be the x, which is 320 plus 80. So So we're going to, again, it's not a question they're asking, but we can always find it. So there'll be 400 gallons of the 60% antifreeze solution once we've done all the mixing. All right, so once again, notice how useful a table is in organizing our information, and when we set it up properly, the equation pops right out of it, okay? That last column is just exactly what we need to come up with the equation to solve the problem. So if you did it already, that's great. If not, try to do it from scratch on your own effort without any help, and repeat that until you actually can accomplish that. All right, so let's go ahead and look at another problem. All right, next we're going to look at a problem that's going to, on face value, look very different from the mixture problem we just did, but once we attack it, we'll see how similar it actually is when it comes to the approach that we need to take to the previous problem. Ralph Chase plans to sell a piece of property for $170,000. He wants the money to be paid off in two ways: a short-term note at 10% interest rate and a long-term note at 7% interest. Find the amount of each note if the total annual interest paid is $14,600. Now, the key word here is the annual interest paid. So that means this is going to all happen within 1 year, okay? So we need to go back to a formula that we already know, and that's the fact that principal times rate times time equals interest. Now, we don't know how much we're going to invest at either 10% or 7%. But once we start to set up our table, everything will start to kind of make sense nicely. Let's go ahead and set up our table. We do know that the total amount that needs to be handled in those two notes is $170,000, and that the total interest expected is $14,600. So let's take a look. So we have a 10% note and a 7% note. Now in this particular problem, we have some of the columns that it makes sense to talk about a total as well. So we'll add that row as well. So we have P, R, T, I, right? Now, again, we don't know how much of the 170,000 should be invested at for the 10% note so that we get the result that we want. So we'll just call it X. Now, we do know that the total to be invested is 170,000. So this is going to be a question mark, right? So let's temporarily put a question mark there, right? We'll fill it up in a minute. So we know X plus however much that question mark is should add up to what? 170,000, right? So it's very easy to find out what the question mark is. Just subtract X from both sides and you get 170,000 minus X. So that's how much is going to go there. 170,000 minus X, which makes sense. Like if this is 50,000, this should be how much? 120,000 to get to 170,000, right? Which is just 170,000 minus 50,000. So think about it. Add these two quantities. What happens? The X's cancel out. You end up with that, right? Which is what the total should be. All right, now we know that, of course, the 10% note is going to be paying at 0.1 or 10%. The 7% note is going to pay at 0.07, which is 7% in decimal form. The term is 1 year. Now the interest from the 10% note is going to be just the product of these three, x times 0.1 times 1, which is just 0.1x, right? And the interest from this note is going to be 0.07 times 170,000 minus x times 1, which is just 0.07 times quantity 170,000 minus x. Now we do know how much total interest we want, right? So we can put a total here too. So for these two columns, a total makes sense. For these two columns, it doesn't. So we will leave those blank. So we know this one, we want to be 14,600. All right, so here is the interest from the 10% note. Here is the interest from the 7% note. What do we know? They should add up to this total interest. And you see how similar this is to the mixture problem we just did, right? So there's our equation right there. So 0.1x plus 0.07 times 170,000 minus x is equal to 14,600. Now we can clear the decimals if we just go ahead and multiply both sides by 100. This one needs a 10 to clear, this one needs 100. So we always multiply by the one that requires the highest power of 10 to clear. And of course we're going to multiply both sides, and because of distribution, all terms by 100, right? And that's just the multiplication property of equality, right? So we end up with 100 times 0.1, that's 10x, plus 100 times 0.07, that's 7, times 170,000 minus x equals, here we get 14600, and then add 2 more zeros. If you want to read it, just count every 3 from the right. So 1,460,000. So let's keep going. So we get 10x plus 7 times 170,000. And then positive 7 times negative x gives me minus 7x equals 1,460,000. So I can combine the 10x and the negative 7x to get 3x plus 7 times 170,000 equals 1,460,000. Now some people just prefer working with decimals, and I want you to know that's fine too. Your numbers end up smaller, but I think it's a little safer to work with whole numbers when it comes to making mistakes. So that's why I usually take this route. So now we subtract this 7 times 170,000 from both sides. So we end up with 3x, these cancel out on this side, equals, now we'll go ahead and utilize some technology. Okay, so we have 1,460,000 minus 7 times 170,000. Let me see, I think I put one too few zeros here. Let's fix that. That's actually 170,000, not 17,000. All right. So we have it correctly on the calculator, so we should end up with 270,000. So now we divide both sides by 3. Now I can't even do that in my head. That's going to be 90,000. All right. So it says find the amount of each note if the total annual interest is this much. So what we just found was the amount of the 10% note, right? So we need to also find the amount for the 7% note, and that's easy. That's just going to be 170,000 minus 90,000, right? So that, of course, is just 80,000. All right, so now we'll answer the question properly. We'll say I'll put it up here, $90,000. I'll put commas and the works, because now I'm going to present my answer to people who may not be mathematicians. So $90,000 at 10% and $80,000 at 7%. So notice the situations are very different between this problem and the previous problem, but the thinking and the terminology and not the terminology, but the thinking and the approach are extremely similar. So pay attention to that. And there are tons of other problems you can handle in the same way. For example, let's say you want to mix pistachios that sell for a certain amount and then cashews that sell for a different unit price, and you want the mixture to cost a certain amount, you would set up exactly the same kind of table. The possibilities are endless. So make sure that you know how to handle these very useful types of problems, and then we'll look at a couple of other problems before we wrap it up for today. Okay, finally, we want to talk about mathematical modeling with linear equations. A mathematical model is an equation or inequality basically that describes the relationship between two quantities. Usually these equations come from actual real-life experimentation, and they are very commonly encountered in various fields of study. Now, a linear model just happens to be a linear equation or inequality that is describing the relationship between two and sometimes more quantities, okay? These next couple of problems we're going to look at, they're going to have a lot of words in them, right? So if you're the type of person who sees words and panics, well, relax, because they're actually going to be much easier than the previous few problems, which we have had to set up ourselves from scratch, because in these next couple of problems, they're going to give you the model to use. So mostly they're just plug-in type of problems, okay? So let's look at them. All right, so in this problem, membership warehouse clubs offer shoppers low prices along with rewards of cash back on club purchases. If that sounds like Costco to you, because it's exactly the model that Costco uses. If the yearly fee for a warehouse club membership is $100, pretty much in line with what Costco charges, and the reward rate is 2%, also very much in line, I guess, if you're an executive member, on club purchases for the year. Then the linear equation y equals 100 minus 0.02x models the actual yearly cost of the membership y in dollars. Here x represents the yearly amount of club purchases. Okay, so you take the amount of money that you've spent at, say, Costco or some membership club, you plug it in here, and this is how much reward you're basically get. Okay. Well, not necessarily the reward, but this is basically how much it's going to cost you, because the $100 that you paid is going to go down by 0.02 times whatever amount you spend, right? So the first question we want to look at, determine the actual yearly cost of membership if the club purchases for the year are $1,900. So you're a member and you have spent $1,900 for the year. You want to know how much you've actually ended up paying for the membership. You did pay $100 in the beginning, but you've gotten some back. So let's see how much you've actually paid. And this is what I mean by these are simple, because you're just going to plug in. Of course, notice this equation is this particular model would be very easy to set up even if it were not given to you, okay? You should be able to set this model up even if it's not provided. So here for this, we're going to find y, right? So we're going to get y equals 100 minus 0.02 times 1900. So let's go ahead and calculate that. So 100 minus 0.02, we can actually do that in our heads probably, but let's be safe, because that's just going to be like $38, right? You got to subtract. So you get 62. So even though you paid $100 for the membership, since you got 2% of the $1,900 that you spent, you're actually paying $62 to be a member of this club, right? All right. For the next part, what amount of club purchases would reduce the actual yearly cost of the membership to $21? So notice they're giving you a twist here. They're not giving you how much you're spending per year. They're saying, hey, you want this amount Y, which is the actual yearly cost of your membership, to be $21. So how much would you have to spend so that, you know, after all the reduction, your actual membership dues have only been $21. So here, we're just going to set it up like this, right? So let me set this one up over here. So this is for part B. So you want 21 to equal 100 minus 0.02x, right? So you know what I want to do for a change? I want to stick with decimals, all right? We're going to solve this one just using the decimal because it's pretty easy. So we'll go ahead and, let's go ahead and move this negative 0.02x to the other side and bring the 21 over here. So that way we get a positive coefficient on the x anyway, which is always kind of nice. All right, so we're going to move the 21 over there, so we're going to subtract 21 from both sides as well. Okay, so now we have 0.02x on this side, positive, and 100 minus 21, which is what? Let's see, 100 minus 20 is 80, so 79, right? Now we just go ahead and divide both sides by 0.02. So we get x equals 79 over 0.02. So $3,950. All right, so if you spend $3,950 for the year, you've actually ended up only paying $21 for the membership. That's what this boils down to, okay? All right, how much would a member have to spend in the yearly club purchases to reduce the yearly membership cost to zero? If you haven't, you know that I always recommend that you try problems on your own first. If you haven't done parts A or B on your own, you should definitely be able to handle this one. So pause the video, see if you can do that on your own, and then come back. All right, so you know how this works. This is going to be exactly like part B, except instead of 21, what are we going to use for Y? We're going to use 0 because we want the actual membership cost to be 0. So we get 0 equals 100 minus 0.02x. Let's do the same trick, move the 0.02x to the other side. So we end up with 0.02x equals 100. Now divide both sides by 0.02, so we get x equals 100 over 0.02, which I believe is, let's see, 100 over 2 over 100, so 5,000. But let's be sure. All right, so let me actually show you a really cool way to figure that out without a calculator. I'm going to get rid of the decimal on the 0.02 by multiplying by 100, right? I have to do the same to the 100 on the top, of course. I can't do something to a denominator and not do the same to the numerator, right? So notice, now you end up with what? With 10,000 on the top, 1 and 4 zeros, and you end up with 2 down below. That's what? 5,000. That's actually the easiest way to handle that. So for part B, the answer we correctly put is use the dollar sign and then 3,950. For part C, we're going to say $5,000. So in other words, if you're a member of this membership warehouse club and you spent $5,000 for the year, your membership has actually ended up being free because you end up getting exactly $100 back in rewards. So notice 0.02 times 5,000, that's exactly 100. So this is how you can figure it out. And of course, if you spend more than that, anything above 5,000, your membership is actually going to become profitable. You're going to make some money on your membership, right? You're going to pay a negative membership price, right? Which means what? Basically, you're making money. All right, so there's that. Very applicable problem, especially if you're a member of one of these warehouse clubs like Costco. And as I say that, of course, it kind of reminds me of the movie Idiocracy, which is a good movie to see. It's a comedy. Anyway, all right. So make sure you can handle this on your own. Notice how much easier it was because we didn't really have to figure this out on our own. Even though this we could have come up with on our own. Usually, at least in this section, they're provided. You know, in a different class, they might model may not be provided. If you take a class where you're doing a bunch of modeling, it definitely won't be provided. But when it is provided, the model, it's really easy to apply. Okay, you just have to be clear about what Y stands for and what X stands for, right? So the key here is that X is the amount you're spending at the store, and Y is the actual membership price that you'll be paying. So once you get those two clear and know what should go where in each step, then you should be fine. All right, here's the last problem we're going to look at today. If a vented range hood removes contaminants such as carbon monoxide and nitrogen dioxide from the air at a rate of F liters of air per second, then the percent P of contaminants that are also removed from the surrounding air can be modeled by the linear equation P equals 1.06 F plus 7.18, where F has a value between 10 and 75 inclusive. When I say inclusive, I mean 10 and 75 are also acceptable numbers for F. What flow F must the range hood have to remove 50% of the contaminants from the air? That's the question we want to address. All right, notice you should be able to do this problem on your own. Please try it and then come back. This is actually even easier than the previous problem, right? Because here you know what P is. It's the percent of contaminants that are also removed, right? So here you want 50% of those contaminants to be removed. So for P, you're just going to use 50. So we get 50. You don't use the percent because the way the formula is set up, they're giving you just the P part. So if it's 50%, you're just using the 50 part without the percent. So here we just get 50 equals 1.06 F plus 7.18. And now we just need to solve that. Again, let's not try clearing the decimal. Let's just work with decimals. So we have plenty of practice with both methods, right? So here I'll move the 7.18 to the other side by subtracting it from both sides. So we get 1.06f on the right side, and on the left side we have 50 minus 7.18, so 42.82. So to get f, we just need to divide both sides by 1.06. All right, so let's go ahead and divide that last result by 1.06. And we end up with somewhere in the neighborhood of 40. So let's say we round it to the nearest hundredths. So we get f is approximately 40.40, right? And remember what the units are for f, liters of air per second, right? So 40.4 liters per second is what the flow needs to be through this vented range hood in order for 50% of the contaminants to be removed. All right, so again, notice how simple that is once you have the model. The hard part here is coming up with that model, and that's where the scientists come in, right? They do a large number of experiments, and based on those experiments, they get some data, and then they fit the data to models which we can then use, okay? All right, so that should do it for this lecture. Go ahead and take care, and we'll see you for the next lesson.